Good morning, everyone. This is Erad Kwakarim. Thank you so much for diving into this video. I hope you are good and well. In this video, I just want to share with you something about logarithmic function. Okay. So we start by first of all some of the basic and also fundamentals of trying to connect between logarithms and also exponential function. Okay, so we do understand that if you have, for instance, a function which is f of x equals to e to the power x. So e to the power x. This is an example of should I say exponential function? Well, okay. And yeah, so let's now go to this. So now that function, okay, f of x equals to e to the power x. Where there is this f of x, you can simply put y equals to e to the power x. Okay, which is something that we all know. Okay, because once you say y equals to e to the power x, okay, y is something that we normally know. Okay, now the e is normally what is referred to as a natural, should I say, natural exponential number, should I say, and which is equivalent to this e is equivalent to 2.7 something. Okay, but for the sake of simplification, I can just say it's equivalent to 2.7. Okay, now the most important thing to have is this kind of an equation, y equals to e to the power x. Okay, yeah, so what we want to connect now, we want to actually connect this thing to something that we are going to call also a logarithmic function. Okay, so this is something like natural exponential function, because this number e is normally referred to as a natural number, for example, natural root, if you like. Okay, now if we have, for example, every exponential, okay, I want to write this one. Every exponential function, okay, every exponential function of let's say g of x equals to b to the power x. Okay, let's say that. Okay, so every exponential function, okay, g of x equals to b to the power x. Okay, now this one has a one-to-one kind of a relationship. That simply means that you cannot have, one-to-many or many-to-one, something like that. So the condition is that this kind of an exponential function is a one-to-one. Now, if this is the case now, okay, if that is the case, okay, if that is the case, then that kind of a function, okay, this function g of x equals to b to the power x has got an inverse. Has got an inverse function. If that is the case, then that kind of a function has got an inverse function. So for every inverse function, we can actually have something that we can, this function can be represented by an equation by interchanging that, okay? So we said that this, okay, b to the power x, okay? This part you can say y equals to b to the power x. Now what you know is that the value of y is normally referred to as dependent, okay? Dependent variable. Okay, so dependent variable. Okay, so if we can interchange that, because there is a relationship between the one up there, okay, so this one and this one, they're the same, except that we are doing some kind of inverse kind of a thing. So now, what we're saying is that y equals to b to the power x. Then this y we can actually interchange by saying x equals to b to the power y. So basically we need to find the value of y. So now y, we need to find the value of y. So finding the value of y becomes so very critical, becomes so very difficult. Okay, and if that is the case, then we have to introduce a method. Okay, so we have to introduce a new method for us to find value of y. Okay, so basically this method is called logarithm. Okay, logarithm. Okay, so this logarithm. So what you're going to say is that y, okay, so we're going to say y is the power of b. Okay, y is the power of b that produces x. So y is power of b that produces x. Okay, so y is the power of b that produces x. So from there now we are saying again that introduce what is known as logarithm. However, if our x is greater than 0 and b is positive, okay, and this b is not equal to 1. Okay, so these are the conditions that you have to understand. Okay, so b should not be the 1, which is the base, and x should be greater than 0. Okay, because say x equals to b to the power y. So let's say if this is 0, then x is negative that, then doesn't make sense. Okay, it's something that does not make sense. Okay, so instead, if those conditions are met, then we're going to say y equals to log, okay, so log of this b x. So now we are introducing the fundamentals. Okay, y is the log of b x, or so log b of x. So meaning y is the power of b that produces x. So this is log form, okay? But we also need to have a relationship in exponential form. Okay, exponential form. Okay? So if y equals to log of bx, then in exponential form you're going to say we are saying y is the power of b. So x equals to b to the power y. Okay. Okay, let me just do this. Yeah. So x equals to b to the power y. Okay. So in the exponential function, in the exponential form, and also above in the log form. Okay. So very interesting. Now, we understand that if we say f of x, okay, so f of x is simply going to give us, so if we bring it back there, it's just going to be b, okay, bx, okay, because x, this one is that one, okay, so log bx, okay. Now this one, okay, this one is the inverse, okay, is the inverse of this, okay. Now if you try to say f of x, sorry, f and then g of x equals to log, okay, now we are inversing, okay. So you write the function f, and then where there is x, you put now, you put g, okay. So log b, log b, of course, okay. Which simply means that in exponential form, you are just simply saying that b, okay, equals to b to the power x. So meaning this one should also be to the power x. So that you can now cancel these bases, okay. Therefore, x equals to x, okay. So let me just end there, and I don't want to actually confuse you so much, guys, so just stick around and be able to pull this through, okay.